Hey guys, I'm streaming a bit of playing with Eagle today. Uh, if you remember, a while back I did a clock, which it wasn't round exactly. It was a square board, but it had LEDs in a circle around it, and then another circle in the middle, and another circle inside that. So there was one for seconds, one for minutes, and one for hours. Now I finished that board and routed it out, and I was going to go and get it printed. However, the board was pretty big and it was going to cost a lot, so I decided against it. So I decided, instead of getting rid of the idea completely and everything that I'd learnt from doing it, I would remake that board into something a little smaller and hopefully more useful in that way. Now, at the moment, I've created the schematic for it. And well, not finished actually, so I've started, and I haven't added in the real-time clock, which I'm going to add in, but for now it's just a display and 80 mega really. So today all I'm going to be doing is routing it up. In terms of size of the board itself, you can see that it where's my measurement tool? There it is. So you can see on here, if I measure from here to around there, so it's going to be about 85. So in fact, we can probably have a look at this on the desk cam, so you can see what size it will be. So we've got, let's try and get that to 85. So 85 roughly. I've got a little SD card in here for scale. So that's how wide the board is going to be. And then if we jump back, there we go. If we jump back, we can have a look at the height of the board. So the height of the board will be, let's call it 24. So jump back onto the desk cam, and then we can change that to 24. Is that going to be around the size of an SD card? No, it's going to be smaller than that. So 24. So around the width of that SD card. So it's going to be pretty small. And well, I'm not totally sure about it. Have I got a battery here? Ah, there's a really terrible battery. So I kind of wanted to have a battery, a single AA battery mounted on the back. And so that's, what is that, 13? Well, I might be able to get away with 26 if I make it a bit larger. But I'll have a little boost converter. That's what these three green dots are over here. That will be the place for the boost converter. In fact, I can show you which one I'm using. Let's see. Did I get them on eBay? I'm not sure. I'll drag over the window in a second so you can see it. Let's see, my eBay purchase history. Yes, I did. So I picked up some of these little boost converters. So it's 0.8 volts to 5 volts. Now it's not going to give me a lot of current to play with. What does it say? Input 1.5. I'll get 40 to 100 milliamps. Hopefully that should be fine. The alternative is to use a little lithium ion cell. So similar to one of these batteries, I'll just be using one of the lithium ones. Do I have one lying around? There are some over there, but they're roughly the same size as an AA battery. There's a lot of you in the chat now. Hello. Yeah, I'm not sure if you caught the start of it where I was explaining what this is, but essentially we've got one of the projects I did in a previous live stream. I never finished. Turns out I didn't like it, so I decided to remake it in a smaller form factor, and that's what this is, using the smallest LEDs ever, I think. Well, not ever, obviously, but If I jump to the desk cam, you can have a look at these LEDs. So those are 0603 LEDs. That's the size of them. Now, generally, I use 1206, which is a lot larger. Let's see if I can pick some up from somewhere. 1206. No. 1206. There we go. Here's some 1206. So these are 1206 LEDs I'm about to put onto the desk. So hopefully, I don't know, my face cam's just gone off for some reason. So these are 1206 and these are 0603. So you can see the size difference there. It's pretty immense. Well, less than immense. They're really, really small. I don't even know if I'm going to be able to solder these. I may have to do some kind of solder paste and either hit it with a heat gun or put it into an oven or something. We'll see. But that's what we're working with at the moment. So let's jump back to the schematic. And let's see if I can get my face back up, because it doesn't seem to be working. Let's try unplugging and plugging it back in again. Not that you really need to see my face, admittedly. You gonna work? Ah, there we go. Right, it's back. Good. So I'm going to be using these 0603 LEDs. Now, they are really small and it makes routing a little bit of a problem. So if I use the rat's nest tool on here, you'll see that I've already laid down a ground plane for the top, but we need to do one for the bottom as well. So let's just do that now. We can delete that line too. So to create ground planes, we're going to use this polygon tool, and we need to select the layer. So let's go for bottom. And you'll notice I haven't changed my dimensions yet. I think this is the maximum board size that you can have in Eagle. So if we just do this, because I've got my grid down to 0.25 millimeters, this is a little bit difficult. You'll know you've done this correctly when you get these dots. And then we'll go to properties, and then we'll change the name to GND, and that connects it with the ground. That's not right. What I meant to do was name GND. And you'll notice I've got some things on the bottom of the board already, so they will be routed around like that. So this is, ooh, you know, it looks ugly like that. So how about we move those out of the way, and then once you move them, it will get rid of that rat's nested bit. So we haven't finished the schematics, so we're going to go ahead and do that. So I'm just going to have a look at chat quickly. What's the SMD chip in the middle of the board? One of these ones. This one is an 80 mega 328P, or PU is it, I guess? No, AU, sorry, of course. So it is just a microcontroller. I don't even know if I'm going to be using that one. What I might do is have it controlled by an ESP8266 instead. But at the moment, I'm just going to be using one of these because I've got some in my kit. So I have some of these very small 80 mega 328s. There will be, I was thinking about putting the ICs underneath the chips, but if you'll notice there, we've got some wires routed underneath the board, and they kind of have to go underneath the board unless I create jumper wires over the top, because we've got this routing scenario here. Plus, these columns, they need to go into this chip here, which is the TLC5940, the PWM 16 channel LED driver. We've also got some resistors that also, I'm using quite large resistors. I think these are 0805. Might even need to change these. I've got some 0805s in 1K, which will be going to these, what ones are they? They're 3906s, they're PNP transistors. So the 1K 0805s will go into those to drive them at the base, and then will probably need to use 1206s for the LEDs because I just don't have any really. Leonid said, but if you'll use an ESP, why use an RTC then? That's just so if it doesn't have an internet connection, it will still work and it will keep time. I'll use a little backup battery. I don't necessarily know what microcontroller I'm going to use, so I think I would like to have it as an ESP8266 board, probably the -12, because we've got this extra bunch of digits at the end of this board. So if you notice on the schematic, we've got one digit here, we've got another digit here, another digit here, and another digit there. And for time, that's all I need. I don't need the seconds, but I have channels left in my TLC 5940, so I've just threw on a bunch of LEDs at the end. So we've got a what is that, 4x5 plus another 2. Those are the 2 dots in between the clock digits, so they'll go there and there respectively. However, in the schematic it doesn't matter where they go. So this was going to be either it might say degree C there, and I could have the temperature here. I could throw on an LM35 to read the temperature, or a DHT22 or something like that. But at the moment I'm not sure, so I'm happy to design the schematic around, design the board around the 74HC595 and the TLC 5940, and then think about driving it later on. It doesn't have to, we don't have to worry about that just now. I just know these are the 2 driver chips for my display, and everything else is can come later. I just need to know that I can connect to these. So I'm going to finish off doing this schematic. So with LED matrices in Eagle, it's relatively easy to route your board. You can just jump down and do stuff here, but when you jump into the board bit, it becomes a bit of a pain to do these. So I'm going to have to go out here, go to change my layer and go to bottom, and it will automatically create a via for me. However, if you notice, this wire up here is quite close to that, so I might have to now move that that via and that wire up. We'll see. It's too close. So the and now I'm going to change to the top side again. If I go to the DRC, it's the design rule check essentially. So I can load up the design rule one that I want to use, which for this board I'm going to use the PCBs.io design rules sheet. That's because I'm going to get them printed at PCBs.io. So whenever you do create a board in Eagle, you're going to need to know what the design rules are. That's the capabilities of the print house that you're going to use. Now, I've got 3 in here, I think. So I've got Lane PCB, L-A-E-N, and that is the old version of the OSH Park one. OSH Park have a newer one, which is this one here. Oh no, sorry, Lane is the new one. OSH Park Layer 2 is the old one. But I'm going to be using PCBs.io. So if I load that up, click apply and check, it's given me a little sort of hashed area here to say that's too close. You've got something overlaying there, so we're going to have to remove that. In fact, we can probably just get rid of both of those and we'll think about it later. And so if I go again to that, check, it gets rid of that, so we know that that's fine. So when you're creating these very small matrices, because that's pretty densely packed. You could make that more densely packed, but it's just a pain. And also they become less readable. So if you were going to have a 2 here, for example, if you push those LEDs closer together, which you could, there's a fair amount of space there, we could reduce that width down to almost that far away from the via. It's enough space around it to do that. We're already routing out this whole section here, so we're not laying down any copper around there. If I go to the rat's nest tool, you can see we're taking away all of the top copper around here anyway. So we don't have to worry about having bits a little bit closer together. But then they become a lot less readable. I've also left larger spaces here, not only for routing, but also because I want to be able to, you'll see that one goes up to there, I was wondering what that was. But so we can have a separation between the digits so that it's visible separation, not just how easy it is to route. Leonid said, have you considered putting them at an angle like the adafruit feather wings? I hadn't considered putting them at an angle actually. That's an interesting idea. It might make routing more difficult, I think. Unless I put it at a forward angle, I guess. That might make it easier. And then I wouldn't need to go up and over. I could just go straight across. Well, I'd still need to do the vias, I think, to be able to do that. Dirty Engineer says, for your information, it's Fab House, not Print House. You're right, it is fabrication. That's PCB fabrication. I just misspoke, that's all. So I'm just going to go ahead and route this. So if you guys have got any questions, then feel free to shout at me and I shall try and answer. But I just really like routing boards, even if I don't print them. I got a couple, in fact I saved this and then I can show you some boards that I've already sent off to print. So Gmail. So I like PCBs.io, it's super cheap. PCB. Let's see if this shows me, well that's got my shipping address on, so I don't want to show you that. All that necessarily. I tell you what, I'm going to snip it so that not that. Hang on a second, I'll be with you in a minute. So I want to do new snip, freeform rectangular snip. There we go, that is better. So this is the new board that I've sent off to get printed. What was it? Let's see if anyone can figure it out from looking at it. What do you think it is? I now remember what it is, so I know what it is. So I sent this off to PCBs.io to get printed. Its final cost for 4 versions of it was $2.94 delivered, which, so that's insane, isn't it, really? That you can get it for that cheap. So this is, and I'll tell you now, but this is, show us your address and we'll send you stuff. I'm not going to show you my address. I've probably done that accidentally on a post bag anyway. So this little chip here is a power path management chip or a power multiplexer. So this will take in, you can see on the solder mask here actually, we've got in 1, in 2, in minus, in 1 minus, and in 1 plus. And so it will take 2 power sources and it will switch between them. So when one drops below a certain voltage, the other one will kick in, and it does it very, very quickly. So you just need I put a largish cap on there, but it will be, and that's on the output. So it will switch quite quickly. So essentially I'm going to have a Raspberry Pi running from this, so USB power into here, and then battery backup from a different power source. So we'll be using something like a lithium polymer battery. I'll use a little boost converter to go into in2, and then if USB goes down, so this is like an uninterruptible power supply, then it should kick in and provide voltage through that. You also get a status pin off this chip, which means I can throw that into the Raspberry Pi and say, whoa, the power's gone out, shut down. So that's what that one is. And then there is another one. Let's pull it up. So the second one I ordered, PCB. Not that one. This is something, the second one I ordered was something I created a long time ago on breadboard. which I can't see at the moment, but I'll snip it out and show you. And it's this here. This is a, in fact, you can just about read it there. I don't know if we can zoom in. No, you can't zoom in. But it's a 1 hertz counter, not counter. I put that on there for no reason, but it will give you a 1 hertz pulse. And it's just a really simple board using 4000 series chips, a little 32.768 crystal and some capacitors and resistors, and all it does is kick out, well, actually it kicks out 1 hertz, 2 hertz and 8 hertz or 4 hertz, so it's dividing those down. And so that'll be arriving soon, and when it does I'll do a little video on it, I'm sure. But how much did that one cost? The board size on that one was 19.75 millimeters by 24 millimeters, so it's pretty small, and that was $2.94. That's for the power path multiplexer, and then for the frequency with the 1 hertz pulse, it is 39 millimeters by 22 millimeters, and that was $5.41 for 4. So it was more expensive because it's a larger board. But again, you have to add in the cost of all the chips that you're putting into that, so really does it work out as cheaper? Could just buy a module, I guess. I haven't done that in this case, just because I really like routing. So anyway, we'll get on with this, I guess. So let's jump to the schematics. So what I'm doing here is I've got rows and columns, and the rows are driven by a 74HC595. They're coming from these PNP transistors. These are 2N3906s, so they're high side transistors. So we're taking in 5 volts. I haven't put the resistors on here yet. They're somewhere on the schematic, I think. No, I haven't got them on there yet, so they will be there somewhere. There'll be 1K resistors, I think, only because I haven't worked out what the current requirements are yet for these LEDs. There'll only be 1 LED on at... No, there'll be more than that on at a time. So each column has its own resistor, so there'll only be 1 row on at a time, and the TLC5940 can sink a fair amount of current. Let's find out how much. It's probably going to change with the package that I'm using, because I'm using a smaller package than normal, because a lot of the times you'll use these two TLC5940s, you'll use them as a dip package. So this is the TLC5940 16-channel LED driver with dot correction and grayscale PWM control. Drive capability is 120 milliamps. So as long as I'm not pulling 120 milliamps, I should be fine. So I might have to rethink something here, but I'm hoping the current draw of these LEDs, I'm probably going to put a 470 ohm resistor down here. I'll figure that out in a second, unless anyone's good at maths and can do the VIR calculation for me, assuming a forward voltage of something like 2.2 or something like that. If anyone can work that out, that would be great. Aviation Anonymous asks, David, are you an electronic/electrical engineer by trade or just a hobby? It is just a hobby. I have 0 training in any of this, so everything I say please take with a pinch of salt. All it is I'm very good at Googling things. That is how I've learned pretty much everything. And just playing an Eagle. I mean, it's so easy to pick this up once you start doing it. The more boards you make, the better you get at doing this. So, is anyone any good at maths? Can they figure out what my current draw would be if the forward voltage of an LED was 2.2 volts? And my resistor was 470 ohms with a 5 volt power supply? Can anyone figure that out? There are calculators online, so you can do that if you want. I hope I've got these LEDs the right way around. Oh, mayday. What have I done wrong there? Right, this is the tricky bit. It's quite easy to get this wrong. The first time I routed a matrix of LEDs, I accidentally connected to the front portion here. I mean, I routed it in the board portion here, and I didn't even notice, and I turned some LEDs around. It's very easy to turn an LED around in here. If you'll notice, you can, let's pull up the rotation tool. You can just turn this around, and it's, because the only indication here that you have that the LED is the right way around is this grey box here and this little dot to show you which side is the anode and the cathode. And sometimes you can get a little bit mixed up with that. And it is easy to do. You don't know whether you've got these labels the right way around because they sort of sort themselves out so they read properly anyway. So if you've not got them all in a simple grid like this, then it can be hard. There is a tool in the in Eagle under, is it ULP, Run ULP? I'm not sure what ULP stands for, but it will position your LEDs for you. There's several ULPs in here that will do that. So I'm not sure which one it is. Let's have a little look and see if we can find it. I'm sure it was move, but perhaps it's not. I don't know. This is the dark art of Eagle. This sort of section. I don't know which one it is. Oh, that's a very useful one actually. BOM, which is bill of materials. If you run that, it will. In fact, let's just run it now. It should save somewhere. It creates a bill of materials, so it lists all of your parts. So if you wanted to send this to someone, you run your bill of materials, and it will detail how many LEDs you've got, what resistors you have, and what value they are. You'll notice here I haven't set a value for any of these yet because I haven't decided what I need. For these ones, which are those ones coming off the... Yeah, those ones are the sync LEDs, so sync LEDs, sync resistors, so I haven't decided what value they should be. And I don't think anyone has in the chat figured it out yet, have they? It's 50 milliamps, is that correct? That doesn't sound right. So the resistor value is 470 ohms. I think it will be around 3 milliamps, but that's because I'm terrible at maths and can't work it out on the fly. So someone will have to do that for me, or I can just use a tool on the internet, I guess. So you'll notice in here I'm not creating vias myself because it's a pain to put them down. So you could just change your layer here and Eagle will automatically create a via for you. Now I've selected this via that's round. You can select an octagon or a square. The drill is the smallest drill that you can select in here, and the diameter is set to auto. And I know there's no wire here that I'm going over, but there will be eventually, so we're just going to keep doing the same format here. It's going to make the board a little bit ugly because you're going to have all of these vias running down the board, and you'll be able to see those clearer than you'll be able to see the LEDs once they're soldered on and when they're not lit. So I'm going to put a little acrylic cover over the top of these, so I'll just glue something over the top, I think. I was thinking about potting it. You can get sort of resin casting, but I haven't looked into that. I think it'd be quite fun to figure out. It looks cool when you resin cast something and it's sort of encased in a plastic block. It looks cool to me, so I'd love to try doing that. You sort of just pour these, you have like an activator, you have the resin itself, and then you activate in it, it solidifies. I like the idea. I made an LED matrix before. It's a little square one. I'm sure you've seen it if you've been around for a while. And I wanted to pot that. And all that was for was just like little animations. It was just so I could learn a bit more Eagle, really. So these will eventually, they're currently on the bottom or the top layer, these wires. Well, wires always are, I guess, but I wanted to do that so I can go to the LEDs, which are going to be on the reverse of the board. So all the chips are going to be on the front because I think aesthetically that looks cool. Who said over 9,000 amps? Some fabs will cover them with mask paint so you won't see them unless they look closer. That would be cool. If they covered up the wires, that would be great. Sorry, I know I'm a little behind on the chat, so it's probably like 20 seconds or something. Let's use a little calculator to figure out what this value would be. LED resistor calculator, hopefully. This, I always use this. I can't do maths, so current limiting. Let's bring this across so you can see it. So we've got a supply voltage of 5 volts. Let's assume 2.2. That is an assumption. I can measure it. Desired LED. Oh, I don't really need to do that, do I? Will it not just calculate? Desired LED current milliamps. All right, let's put 8, 7, 8. Calculate. Okay, so let's take it down to 6. Okay, so it's going to be 6 milliamps. I can't remember, what did I say that it was going to be? I think I said something lowish around there. I think I might have said 3, so that would have been something like a 1K, I would have thought. But that should be enough to light them. We can test it out before we decide which resistors we're going to use. But I do have some 0805 470 ohm resistors, so I should be able to use those. And that would mean we have 16 times 5. I said 3, yeah. I thought I'd got it wrong. So, like, don't judge me here, but I'm actually going to have to use a calculator. So is it 5.9 times 16? Because we're going to have one LED on from each one of these columns at a time, so that's 940 milliamps. And they won't necessarily all be on at once, but let's assume that that's possible. We will only have one row on at once, so the 74HC595 will only be turning on one of these transistors at a time, and then we're going to sort of scan down the column, scan down the rows. So let's say if we had a 2 in here, we've got 3. There's a 1 in here, let's say that's 1. I don't know, it's possible. It's certainly in the top portions and the bottom portions for them all to be on at the same time. That is possible. But there'll be a lot of times when they're not all on, so the current draw won't be 60 milliamps or more. How much did you say? 94. So yeah, I like underdriving LEDs. So the maximum current probably for these ones would be, or the recommended current would probably be about 20 milliamps, I would assume, at like max. So that's probably with a 100 ohm resistor or something like that. In fact, we could use a calculator to figure that out, but in fact, should we? Let's have a look. Okay, so let's say 20 milliamps is what they advise. What are we going to assume? 150 ohms? 140. That's a close enough guess. No beer tonight. It is Sunday, so I can't drink because I have to go to work tomorrow. I may nip out and get a cup of tea shortly, but no beer, unfortunately. I can't remember what I was saying, so I'm just going to carry on routing this board. So I like to have things looking sort of nice, because you can see these details on the board. Even if it's got solder mask over the top, you can see these small details. Certainly you could see it on the reverse if it was on the bottom side of the board, but I like them to be nice-ish looking. One thing I could have done here is have all of the LEDs on the back of the board on the reverse, and I could have tried to fit in some of these chips over the top of these LEDs, but as you'll see, it's a little bit of a minefield with all these vias all over the place. So it's not going to really be possible. And I don't think it's really worth the effort to go and do that. Sort of gone out of order there a little bit. So I'd love to hear what you guys are making at the moment. I know I'm pretty much always designing up a PCB that I may never use and you may never ever get to see. But the two that I showed you earlier, they'll definitely be arriving soon. And once they do arrive, I will do a little video on them. The 1 hertz frequency generator, I don't know what to call it. What would you call it? The 1 hertz pulse thing will be part of a project that I'm creating, which is going to be a frequency counter. And I mean, I'm the first to admit that when I don't know something, most of the time. And I would like to make one. I don't know how they work, but I know how in my head I'd like one to work, and that will be counting a frequency using, what are they, 4027s, I think, or is it 4026? I can't remember. In the 4000 in the 4000 series playlist on my YouTube channel, I've been covering some chips, and some of them count up, and so there's a 10 bit counter, and then there's a rollover for that to have the next count up. So I could put a bunch of those in a row and then have those go onto 7-segment displays using, what is it, 4056 I think is the chip that does the 7-segment displays, and then that would be reset every second by this frequency counter. So I'm not sure how accurate it would be, but that would be the idea, that this 1 hertz frequency would be resetting the display of the frequency counter, and so I would have this number essentially at the end of the second, hopefully, and it would work well enough for sort of high frequencies, because that 1 second drop, provided it was going at many hertz, or even a megahertz potentially. I mean, I would take off some zeros at the end because I wouldn't need that much accuracy. Hopefully you wouldn't be able to see that it was refreshing, but you know, it's an experiment, so we'll see if it works out. If it doesn't, then I'll think of something else, I guess. You can measure frequency in a microcontroller just as easily. I just want something that's basically all sort of CMOS chips, so I'd like to see if it would work out. These aren't connected, are they? So let's jump back in here. Of course they're not. I've not finished that off. So let's go through and do that. And I'll see if I can read chat at the same time. I don't know if I can actually. It's a bit difficult. Do I know of a good way of driving a matrix of LEDs? Well, there's a max chip that you can use that's in most of the 8x8 matrices. It's a max 2789, I think. That max chip will drive your LED display, and it's perfectly suited to that because it's created for that. So you can use those, or you can just drive the columns and rows yourself, which is what I prefer doing. I like using 74HC595s. They've got a current capability per pin of around 20 milliamps maximum. So if you're driving your LEDs low like I do, actually you can drive those columns and rows yourself if you want to, or you can drive each LED individually. So you can use those without a worry about it, but there are some chips like the TLC5940 that will manage to sink a lot more current. But then you have to look at how your circuit works. In this example, I'm using it is a 7 rows here, but really I'm only using, to properly drive anything, I'm using 5x16. So the TLC5940 is sinking the current for me. And that's the thing you have to worry about with your matrices, is sinking the current. It's nothing else that you need to worry about really. And maybe speed in some way. If you're going to look at an 8x8 matrix, you might have to worry about the switching speed. So if you're going to do each LED individually, so you've got 64 LEDs, there's some maths for you right there, then you're going to have to worry about the speed of it. But I mean, microcontrollers are very quick and you can shift out data very quickly. So Really, in my experience, you don't have to worry too much, but the larger you get, the more you have to worry, and the more you might have to consider using different circuitry that will shift out or manage higher levels of current. So you can run more LEDs on a column or on a row, or whatever configuration you've got. So in this one, I've got more LEDs in each row than I have in the column. So I need to worry about driving that row, so I'm using a PNP transistor. I could have used an NPN and stuck it on the bottom, but and perhaps fed that into the TLC 5940, but this approach should work well enough, hopefully. But if you guys have spotted a problem or something that I've done wrong, please tell me, because we could be here for a while if not. Now, have I done all of this? Those look all connected. It's just this bit here, isn't it? And then we should be able to route most of the rest of it. So, who's Mr. Carlson? Can someone, is that his YouTube channel name? Did he just make a frequency generator? Is that what it was? Not generator, a frequency counter. I don't think I know who Mr. Carlson is, so if you could let me know, that'd be great. I would love to look it up. Even if I've got the wrong idea completely, I'm still going to go ahead with it and see what happens. It'll be a nice learning experience. Right, I think that all looks like it is routed correctly. Let's have a quick scan over the columns and rows and just make sure nothing looks really out of place. No, that looks fine to me. We're only routing to the resistors at the moment. I made it with Nixie tubes. I literally have no idea how to say your name, but I'm going to give it a go. Axolotti? I'm not sure what you mean. Can you explain it a bit more? Make a shortcut about the layer. I'm not sure. Oh. There we go. Do you mean a keyboard shortcut for switching the layer? I bet there is one, isn't there? That would be good. I might have a look. It would be nice if there was one to switch from the bottom to the top. If anyone knows it, please tell me. I bet there's... Can I just press numbers? No. No, I'm not going to press any keys because I might get something wrong and delete things. Yeah, it's a good idea to have a write a sign and then add a new one with layer top, another layer bottom. I'm not quite sure how to do that, mate, but it is a very good idea, I have to admit. It's certainly something I would definitely use a lot. But for now, I'm kind of happy doing this. And it's not too slow. I mean, it's not as fast as using a shortcut, but all I'm doing is moving my mouse up to the top of the screen and back again. Oh, I wanted to show you something. I can do this while talking, so let's jump back to the desk and we'll remove all of this junk. Do any of you know what that is? I guess some of you definitely will know what that is, but does anyone know what model that is what I'm asking. I'll be interested to see if you've seen the other one. So there's one, and there is the other, which I picked up off eBay recently, and I've been struggling to find one. I've been looking for one for a very long time. that is a Raspberry Pi Model A, so it's the very first version. It has no networking on board. You'll notice a couple of differences between the two. Can I get them both in shot? I'm not sure, let's see. Except for they're not the right orientation. So you'll notice there's some unpopulated sections. So we've got the space here for the Ethernet chip, which is just there. Let's see if I can read what that says on the chip. SMSC. I don't know the chip itself, but and it doesn't have the Ethernet. I don't know what that would be called. Ethernet port, I guess. Doesn't have that in there either. So, but for all intents and purposes, it's essentially the same. Does it have the same amount of memory? This is the back of the board if you're interested in seeing the differences. We've got an extra crystal here. That will be for the Ethernet chip, I would imagine. But everything else looks largely the same. You've got a few differences here with some of the through-hole bits. This one may have been soldered at some point. No, it won't have been because I didn't do it. So that's been my board from the beginning. But I got the Model A on eBay, so I'm very pleased to be able to add that to the collection, essentially. I was planning on using it for something, but screw it, I'll show you. So I've started a new project. I'm always starting projects and never really finishing them. So this is a little portable TV. God, this camera, it's just so close in. You're going to have to trust me on this. This is a portable TV. I could pop some batteries in. It of course won't work. It's an analog TV. Mayday. And so we don't have any analog signals being broadcast anymore in the UK. So it will not pick up anything. However, so there it is, scanning for signals. But it's not going to find anything because we have no analog signals anymore. However, it does have somewhere on here. This is not going to focus. Oh my word, it does. Hang on, let's just turn it around. So it has an audio video input bit there. So it's a 3.5mm jack and it takes left, right and video in there. So you can get little adapters for it. This one has a weird pin out, so I'm going to have to either remake a cable or I will have to open it up and solder wires directly to the board inside here in order to use this with a Pi Zero, which I'm hoping will fit. If I destroy that battery compartment, I'm hoping I can fit a Pi Zero into the case. I'll throw a lithium cell in there and a 5-volt boost, and then hopefully I'll be able to use this as a tiny little Pi with a screen. Now, I admit that it's absolutely pointless that I would use that because you know, you can get a screen that's going to be a lot smaller. You can fit it to the exact size of the Pi if you wanted. You can get these really tiny displays, but this one's a little old school TFT thing and I like the look of it. It uses 400 milliamps just to run the thing. I've tried it on 5 volts and 6 volts. It takes 6 volts, it runs off 6 volts, but it works on 5, so it's not a problem, but it will run at 400 milliamps regardless of the voltage, which is odd. It didn't change at all. So 400 milliamps plus whatever the Pi is drawing, so it could be close to 800 to 900 milliamps potentially, depending on whether I stick Wi-Fi in it or if I'm writing to the SD card or reading from the SD card a lot. I don't know, we'll see. But I thought I would just give you a little preview of what that's going to be. At some point that will happen, but for now it is just going to sit there until I decide when I'm going to start it. Is it short of a header pin? No. So let's jump. In fact, I'll show you the jump back to the desk cam, and then it is short of more than one header pin. So these are the old style Raspberry Pis. they have a 26 pin header there, and then we have the new one with the 40 pin GPIO. So these are exactly the same, they're just not lined up. There we go. So the new style has more GPIO. Is it an entirely different chipset? It is, isn't it? So this is the BCM 2709, and that's probably the 2708 or something. So they're very different than the new. Is that the B plus or this is the B plus, but it's the Raspberry Pi 2 version. I've got the B plus somewhere. I don't know where it is. And not the 2 version, but the B plus is around somewhere. I know 800 milliamps is a little scary. However, it's not like it's all going into heat. It is going into driving light through the back. Most of it's probably going into the backlight for that display, I would imagine, and also the analog circuitry for picking up TV signals, which I may be able to disconnect. I'm not sure. I don't really want to go plugging around in there and find out that I've ruined it. That would be upsetting. However, I think it's worth trying, maybe cutting a few tracks or desoldering a couple of components. I don't know. We'll see if there's anything I can do to change it. But I really like the idea of using the Raspberry Pi in that to have, I mean, I could maybe have it run a playlist of videos. When you turn it on, it will play some YouTube videos or something modern on a really, I mean, it's about 20 years old, that thing, so something modern on a device like that would be fun. Now, what am I doing here? I'm just going to go straight down, am I? Okay. I've got the A Plus as well. I pretty much got all the Raspberry Pis. I was going to do a little video on that very subject. There's one that I don't have, and I don't think a lot of people do have it actually. It's the compute module. So it is sort of like a... should we do this? Okay, let's do that. So it's kind of like a RAM chip, like a... Are they called DIMM slots? I think that's an old term for them. It was a weird thing back in the day. SO-DIMM, I think they were called. Sounds funny now. But yeah, it's essentially, it slots in. So it's got its contacts along the bottom of the board, and you slot it into a sort of receptacle. So it has a motherboard it slots into. So just like RAM does in a computer. But I don't have one of those. They're kind of expensive and not all that useful for me, really. But if I was doing an embedded project and I wanted to have a Raspberry Pi in the project itself without having this sort of development board, then I might consider using it. You'd have to do the voltage regulation and stuff off the board, and you would probably have to have your HDMI connector off there. I don't even know if it's got HDMI, an HDMI chip in it. I don't know much about it, honestly, but they do look interesting, so I would love to pick one up. However, I haven't seen them for a cheap enough price. I might just pick up the actual compute module itself without the motherboard, which is the expensive bit, just to have it in the collection. But it is it's an expensive thing to do if you're just going to have a hobby where you pick up development boards. Just press the middle mouse button to place a wire/chain. No. Oh my word. Foo Fighter 1933. You were a genius. That is brilliant. If you can see, I'm pressing the middle mouse button. I can't lift my mouse up that high, but pressing the middle mouse button changes the layer from top to bottom. You were a genius. Thank you very much. I can't believe that. That is brilliant. That is amazing. Right, so change. Look at that. Oh. Change. Oh no, change. Change. Perfect. Thank you very much. I think that's a great tip. So, Foo Fighter 1933 just said that if I change, because this chat won't be available later, so people won't be able to see it, but you can change the layer that you're using by pressing the middle mouse button. And it will also, when you change layer in Eagle anyway, it automatically places a via for you, which is great. It's the easiest way to place vias. Otherwise you have to place a via and then name it, and it has to be the same name as, so whatever this one is, which is $17. So I'd have to say that, and then it would be able to connect to that. I'd be able to connect to that via. Genius, absolute genius. Can't believe it. Well, I'm less scared of making these boards now when I can just press the middle mouse button. Oh. Yeah, I'm using PCBs.io. Now that LED is out of alignment. Look at that. That would have wound me up if it was actually printed like that or fabricated, or I'm going to get told off again. But yeah, I'm using PCBs.io. They're sort of started by a company called Digispark. So check them out. They're really good. They created Digistump, sorry. They created a board called the Digispark, which was an ATtiny 85 board, which had it was able to communicate with the computer by plugging it in via USB. So you don't have a serial port on the ATtiny 85. However, they created a way that when the bootloader loaded up, it would look for that USB connection first, and then it would virtualize a serial port, so it could be programmed via the Arduino IDE. And I think it was probably one of the first ones to do that. So it was before the Adafruit one. They did one, I can't remember what that was called. But it was great. It was a Kickstarter. Oh, I've just clicked the rat's nest tool and it looks horrendous. So let's get rid of that. So yeah, it was a Kickstarter, and the guy, Eric something, I've forgotten his name, but he was a really nice fella, and he sent me a board to review at one point. Or did I just do the review and talk to him about it? I think I might have just done, I think I picked up the board from the Kickstarter and I bought it and then did a little review on it. It was a long time ago. God, I can't even remember when. You'd have to look back in YouTube history to find that one. Probably about 3 years ago, I think. Anyway, he started this thing called PCBs.io, which was sort of competition for OSH Park, essentially. And I had a look at it and I thought, well, why not give it a go? There's lots of them that I haven't tried using. There's one called Dirty PCBs, which looks very promising. It was started for a guy and his mates, essentially, and he had a fab house in China, said it right that time, fab house in China who would do boards for him relatively cheaply in sort of short runs, and then he opened it up to be a website that everyone could use. And so I looked at that. There's also a OSH Park, and there's another one. They contacted me recently to try and do some kind of collaboration where they would Dirty Engineer. It's PCBs with an S on the end, just in case you've gone to the wrong one. What was the other one? Let's have a look. They sent it to me via Gmail and I immediately dismissed it. I don't like it when people send me sort of business stuff via email in a kind of a weird way. They often do it and it's quite annoying. PCB Way, that's it. So can I show you that page? Yeah, screw it. Okay, well you can see it. So this is, they sent me this email, PCB Way's online services team, and they're deeply impressed by your project. We're a PCB manufacturer with over 10 years experience. Now as low as $8 for 10 pieces, which isn't very cheap really. And this is their website. and it's just, you know, it's not very nice. So let's have a look at PCBs.io. Make sure it hasn't remembered me. So PCBs.io is super simple. So we can just load up a board and it will display it in the browser in a very similar way to OSH Park. Let's have a look at the Audio Cube. So this is one that did I even send it away to get printed? I think I only sent partial bits of the Audio Cube to get printed. So I'm not even sure which version this is. It's probably a terrible one. It's probably not the SMD version, but it will generate thumbnails of your board, which is really nice, and then it will tell you how much it's going to cost. So hopefully this is a 50mm by 50mm version, although that sounds quite small. We'll let it do its thing and then we'll come back to it. Notion Sunday says, how many subs did you have when you started getting offers? I don't really know. Probably, I don't know, you'd be able to see. Well, no, I'd be able to tell. I'll jump into my video manager and then I'll scroll back a few years and see when I did my first given stuff review. Let's see. So not then. It was it. So DigiStump sent me the DigiX board, which was one of the first Wi-Fi Arduinos. Essentially, it had Wi-Fi on board, and that was pretty impressive. Or did I buy it? I can't remember. I might have bought it. Do you know? I think it was. Difficult to know, really. I think around 2014, so around 2,500 to 3,000 subscribers before companies decided that they wanted to get in on my audience. I don't accept things if I think that you guys won't be interested in them, or if it's not something I'm already into, so I've just done that without using the middle mouse button. So I'm not, in no way do I ever sell out to anything. So in fact, the most selling out thing that I've ever done was the Reichelt build that I recently did, and it wasn't selling out in that sense. They sent me a bunch of stuff that, you know, if you were going to buy that, it would cost a lot of money. But I thought some of it would be useful to some of you. Not all of it, by any means. I wouldn't expect any of you to go away and purchase all of the stuff that I used in that build, because it's expensive, and most of you will already have a Raspberry Pi. Some of you won't want to use the DAC that I used. You might want to use your own kind of either just use the 3.5mm jack on the board, because you don't need that kind of audio file quality, all that kind of stuff. You wouldn't have used the Bluetooth speaker that I just plugged a cable into. So they sent me a lot of stuff and I used it, and I was a bit selling outy, I think, but it was stuff that hopefully people are interested in, so I wouldn't do it normally. But yeah, it was a while before anyone started sending me stuff, and I'd never even expected people to send me stuff either. The stream started at 8 o'clock, so it is now 9:15. Typing the address in another monitor. Yes, I was typing the address in another monitor. Because otherwise it would be a long stream of stuff that's completely unrelated. Google not only gives you web addresses that you visited, but also ones it's trying to guess that you're using. And I don't fancy advertising other people's websites while on my stream, so certainly not ones I don't choose to show you. And also, God knows what could be on there. So anyway, looks like we're pretty much routed here. Now the next thing we have to do is connect our, these will be 1K resist. No, these will be, I don't know what these resistors are. So these are the 470 ohm resistors, aren't they? They were meant to be the 4K ones, so they don't need to be here. They need to be on the other side of the board, I think. So they're probably going to go one there, one there, one there, and we'll mirror those. Don't tell me there's a shortcut for this because I'll not be happy if there is. So let's mirror them all so that they're on the bottom side of the board. You like Dave Jones? I think everybody who likes electronics likes Dave Jones. He is a very, very clever bloke. I don't really have a lot of space here, and that needs to go to that one. Oh, easy. Okay. We don't have to do it perfectly. Let's pop this here. So we're not quite sure where I'm going to put all these things. So where am I going to put this one? It can't really go there because I need to get the other side out and up to one of these, up to the TLC 5940. So this is going to be difficult. Oh, it didn't start at 8 o'clock, did it? It was meant to. I did start streaming at 8 o'clock, but it turns out I got my stream key wrong, so it wasn't streaming to my channel. I'd forgotten to mention that. Yeah, that did happen. And it often happens a lot. I'm not in any way a professional streamer or a professional anything other than web guy, which is my actual job. So that's what I do professionally. And I'm professionally bad at it, pretty much. So let's try and put these in a reasonable position. Do you know what? I might have to move this wire. I think we're going to. I want to keep these all in relatively the same position. It's nice to have things fit properly. So let's remove that. And we'll take it a little bit further out, I think. So remove that there. And we'll stop there for a second, and we're going to move this via, because I think, no, it's about the same distance as every other one. That's fine. I'm happy as long as that's the case. Now that is looking like a whole big mess of stuff, isn't it? Right. I think that looks okay. So if we do, I say we, I'm just going to let you claim some ownership of this since you're sitting and watching me do it. If we put these in the same position on all of these bits, then we should be golden. Whoops. No. That's what I want. So roughly in the center for each one. This one isn't quite the same because we've got stuff around it, but as long as it's sort of similar, then it is okay. Yeah, why not use the auto routing tool? That would be brilliant. Should we do it? Should we have a look and see what it does for us? I'm not even going to move those resistors. Let's save first, just in case anything really bad happens. So, continue. Let's see what it does for us. I would imagine it's going to be awful. It doesn't really have much to do, honestly, because most of these are already routed. So it might create some weird, crazy tangle of mess up here. Probably a bunch of wires. We're still waiting on it. It's not created a working solution just yet. The bottom wire can be routed up through transistors. The bottom wire can be routed on the top between the transistors. So this one, yeah, it could come around here, that's true. I'm happy with that though, it looks okay. I do want a little bit of space around these LEDs anyway, so I don't mind routing around them. I haven't really thought about mounting holes yet. I don't know if I'm going to need any, but once it's routed I can move this around and give it more space if I want. This is not going to work out. Oh, I haven't clicked start yet. Wow, that was good, wasn't it? So this is what it this is what it's decided. Well, I haven't given it a lot of options, honestly, have I? Because I've not got the stuff in the areas where I want them anyway. So let's just cancel that, and hopefully it won't crash. There we go. Let's move our thing out of the way. Now, the auto router is one of the worst tools I've ever used. I would hope that people don't use it, or if they do, they just use it to see if something would be possible, which I think is the only reason it's useful, is to just give you that little tiny bit of hope that the crazy board layout you've gone for is worth it or will work. Oh, is the upload finished? Sorry, I'd forgotten about that. Let's see. It has. Just make sure it hasn't got my name on it anywhere. It hasn't. Okay, my name, my address. So this is the uploaded board. So it's taken the name from the file name. I just uploaded an Eagle board file, BRD, and it accepts all of that. So this is a 56mm by 56mm, roughly. It's not quite square. That's annoying that it isn't. I thought it was in Eagle, but this is what it comes out like. So they use black solder mask, and it looks beautiful. And you've got sort of, you know, your gold-plated pads and stuff, and they've even plated the mounting holes there. That actually looks quite nice. So this is the brain. Is it the brain board? I'm not sure. So we've got the SD card on there. I can't really remember what this one was. This might have been a bit more of an advanced one. I think it was. So this has the USB. We've got a 3.3 volt regulator. We've got the micro SD card. That looks like it's a TX level shifting, a Texas Instruments one. It's like 1008B or something like that. That chip there is probably, is that a boost converter? That IC there is probably that would be a Max 1811. This would be an LT1302, so it's a boost chip. This board didn't work. And you've got the 80 mega 328 here. Yeah, that's everything on one board, I think. I think I was going for a single board solution at that time. Previous boards were like three boards, so you had, this one would have had another board. So it would have a speaker board, a battery board with the boost and with the charging circuit, and then the other one would be the brain board, which would have the 80 mega. It would have the accelerometer, which is just there. That's the ADXL345. And it would also have the micro SD card and any kind of level shifting that it would need. So that's what that was. But it comes out quite nice. So I would have had to pay $18.67 for that one, which is kind of a lot, isn't it? But if that's the size of the board, I guess. But you can get rewards by sharing your designs. So if someone orders copies of your board that cost $20, you'll get $6 credit. And I think it goes down to smaller sizes. So it's $20 divided by set times 3 times 0.10. I don't know what that would work out in real world examples, but that's what it came out like. So it does look nice. So I'm hoping when they arrive I'll be able to show you exactly what they look like. But I don't know when they're going to turn up. Let's find out whether they're in fabrication, because I can do that with the email I got sent. So the order status for the power multiplexer, it's awaiting panelization apparently. So can I scroll up without you seeing? Yeah, brilliant. Oh, no one look at that number. So it says awaiting panelization for that board, and the other one says it's in fabrication, so that's good at least. Right, where did the bloody window go? I'm not sure what you'll have seen there, but please don't call me. Right, so we'll get onto this. Let's pop all of these in the area that we want them. I am determined to finish this board this time and actually send it off to print. So we'll be able to, excuse me, we'll be able to have fun in soldering up some 0603 LEDs, which is going to be a little bit of a nightmare. You know, those don't look quite right. I wonder if the separation is different between this group of LEDs and this one. I'm not sure. Well, I've had dreams about those kind of accidents happening where I've shown stuff on stream that I shouldn't have done. We can pop that one there, can't we? Slightly in the middle. No. Oh, sugars. That one needs to go there. And then that one needs to go there. Thomas, there are services like that, but you'll find generally what they do is you'll have a fab house that will, notice I said it right that time. You'll have a fab house that will say they'll do a full service. So essentially they'll create your boards and they'll also put the parts on there for you. But it will cost a pretty penny. It will be very expensive. You don't get to say where they pick the parts from. They'll use their own component supplier. It will be expensive. And also, you may end up with replacement parts if they don't have parts available. So you might get something that's not the same spec that you really wanted. Again, I haven't used a company like that, so I haven't used services like that, so I would done this wrong. These are the wrong way round. But I don't know of any companies that do it. You'd have to go to some companies in China, or if you're in the UK, there'll be lots of very expensive PCB manufacturers in the UK that will do it for you, full service fabrication houses. Well, at the moment, it isn't a clock at all. It is meant to be a clock. However, there's nothing in here that's going to tell the time at the moment. The 80 Mega 328 is just a microcontroller. It's not even connected to anything yet. The idea will be that I'll put on a DS23232 3159. I don't remember the number. But it's essentially a better version of the DS1 307 or whatever. It's a little real-time clock chip. I'm not doing this for any particular reason other than I started making a clock a while back and I never finished it, and I thought it would be nice to actually get it done. I don't need a clock. They've got plenty of sources of time, or the measurement of time, in my house, in my pocket, on my phone, on my wrist if I wear a watch. So I don't need this. I just fancied having it. Plus, I was going to break out the pins so that it will kick out a serial value of the time as well. So I could just, for no reason whatsoever, have it serially coming out as well. And I'm going to have a couple of sensors on here as well, actually, that I haven't spoken about, but I'm going to make sure that I've got, this is the wrong part. I'm going to make sure that I have an LDR on here so we can measure light values, and then the PWM the TLC 5940 does PWM, so we can lower the brightness of the LEDs dependent on the ambient lighting. And so that'll be fun. And I'm also going to put a temperature sensor on there, probably in an LM35, something like that, so we can look at the temperature. But I might do temperature and humidity as well, so that we've got something a little bit more interesting. All right, start routing these in. Now these ones are super easy because we've already got wires connected to there, so it can connect at any point in that column. Oops, that one's the wrong way around. I don't like to have the grid visible because sometimes I won't be able to see these the small signal lines. I've missed plenty on occasions with having the grid visible. So, you know, if you put a part down, there's sometimes like a really tiny little line. So I don't like to have the grid visible. I can judge it by eye most of the time. And it snaps to the grid anyway, so most of the time it's fine. Hello, what's that there for? Okay. That's interesting. So that's running that column over there. Well, that's good because it's a bit closer to the... Is it good? I might be better off with it over there. I think I am. Oops. Undo, Control Z, literally one of my favorite commands on the PC. Let's pop this over here. Super. I'm going to say your name's Bobaloo because I don't want to say that word out loud, but do I visit my local hackspace? I'm a member of my local hackspace. I've been a member for 3-4 years. I've been twice. I went on the first day that they started a hackspace in Leicester, and I went along thinking, oh, this would be cool, and then I never went again. Well, no, that's not true. I went the second time because the first day was like an open day, and then the second day was they had an Arduino session on, and at the time I didn't know an awful lot about Arduino stuff, so I went along and thought, you know, this could be fun. But in the end I didn't find it very useful. I've done the rat's nest. There's also that's so no, I don't visit. I am going to donate some stuff to them though. Because I've got an awful lot of stuff that I've collected over the years, so I would like to give a little back, I guess. I tell you what we're going to do. We're going to do a little bit of a cheat. So yeah, I'd like to give some stuff to them, but no, I don't go to it. I think a lot of the time people go there to share knowledge and learn from each other, but I learn just fine from the interwebs, so that's what I tend to do. I don't like where this resistor's going. I might just stick it. I'm just going to stick it there. Does that look terrible if it's just there? Screw it. And then well, that, I don't know how to make that a via, but I don't know how to get rid of the rat's nest with a shortcut. Wouldn't it be great to, not the rat's nest, get rid of the ground plane, not render it? That would be nice. I think I'm going to have to go with a little via over here. There we go, that looks fine. I'm not bothered, that's all right. Again with the edge moving on the flood fills. How do we change it? How do I get rid of that flood fill? I mean, I want it there so I can see how the board's going to be routed. So if it's going to drill out a load of copper or etch away a lot of copper that I don't need to, I'd rather leave it in. But this is the only way I know how to do it, is by just moving my polygon around. That's the only way I know how to do it. Rip it up. Oh my god. No, how do you do it? What, just click on it? Oh my. Ah. Oh. Okay. That's good. Thanks for letting me know that. I appreciate it. So now we're getting into the difficult territory where I have to start making some actual choices with my schematic. Next question, what about those LED labels? Will you smash plus delete soon? I will. I will be keeping the values or the name portions on my resistors and on my transistors, but I will put them on the other side of the board, so they'll be on the reverse. But with the LEDs, I don't need them. I'll be able to figure out which way round they go, so I will get rid of it. I'm going to leave on these ones, I think it actually prints these bits on the board, so I'm happy to leave that. The LEDs will cover it, but I will get rid of them, yeah. But for now, I'm not going to bother. It might have been better to do that earlier, but I know it's a big old mess. In fact, you know, if it's triggering you, we can remove the layers that have names and values so you can't see them. Is that better? God, it's actually gotten rid of too much. I've removed too much. That's better. Shortcut keys, I could definitely do that and should, but I haven't gotten around to it. So, we've pretty much got everything routed there. If you ignore the power, although that's, of course, because I've ripped up the ground plane, it's not connected there, but so we need to connect power. We've got our TLC 5940 now to route in. So let's start naming these. So that will be TL1. So all I'm doing is naming these, so it's going to look very similar to this over here. And the reason I do that is so that my schematic can look a little cleaner and I don't have to route all the way over here. I can just stick a line on there and name it the same thing, and it connects those two wires together. I think they're called nets. I think that's what it's called. Oops. You're going to have to put up with them in here. I don't know how to take away the LED names on here, and I don't think I'd want to. I quite like to see them. But you're right, in the board itself, you don't want to see them. In fact, I'll tell you what we'll do in a second. I know it's not completely routed, but we know roughly the size of this board. So let's change this to be from 100, let's go down to 20, did we say 26? Was that it? 26 to 80, no it wasn't, was it 75? 75 and 0 to 26. So I'm changing the board dimensions. So, okay. Well, that's not quite what I wanted to do, is it? Let's try that again. So to 75 from... Why does that... Is that... That's better. And then properties on that one from 100 to... So we don't want it to be... I think I said it was 75. No, it's more than that. So let's try 80. No, I'm not happy with that. 85. So 85. What does that one do? Oh, I see. So that's going to 85, isn't it? No. That's right. So from 85, properties there, 0 to, this is the one, this is it. So from 26 to 26, and it needs to be to 85. That's right. No! What is the bit that I need to do? So 26, 26. So it's gone to there. From 26 to 0. What is the number I need to change here? So 26 is right. Ah, there we go. 85. It's that blooming number there. So that's our actual board. Roughly. It's probably going to be a little bit smaller than that. So let's save it and let's find out how much it would cost at PCBs.io, shall we? So it shouldn't take very long to do, hopefully. We'll just leave it on the screen and I'll catch up on the chat. Which edition of Eagle is this? God knows. Let's find out, shall we? Help about Eagle. So this is 7.5.0 and it's the light edition. So I think that's the most recent version. So there we go. It's going to be $13.33 for 4 of them. And we're going to make it a little bit smaller than that. So maybe the price will go down a touch. It's going to be 85 millimeters by 26, but probably a little bit shorter. So maybe we'll go to 82 by 26, but that's what we're currently looking at, I think. And I'm probably going to try and stuff on a couple of other bits in there, so we'll see what that comes out like. But it looks kind of nice. Can I get a bigger version of that? So that's what my vias are going to look like. I did think they were going to be kind of ugly, and they are. And Dave, you must be triggering with all these LED 26 bits all over the place. There's a lot of them. I'm not quite sure about the placement of some of this stuff. I might throw those transistors onto the back of the board so they're less visible. But I like looking at the stuff. I've got this big blank space up here that will probably be to route a bit of the TLC around, but I'm not sure. Super asked, are the free editions a good start for a complete noob? Yeah, they are. There's a little bit of a learning curve with Eagle, honestly. Even on this stream, I've learnt two things. So lots of people pick different things up in different ways, I'm sure. But even people who consider themselves experts in Eagle won't be using the ULP tool. It's not a tool, language programs, there you go. So these are like, essentially it's a program that will run and perform loads of tasks in Eagle that might take you a long time to do, or that you would be unable to do, like spreading LEDs out into a circle and stuff, and calculating all the right angles to go around that circle and stuff. So there's loads of stuff in here that you won't need to use though. So just if you want to wire up a simple circuit, Eagle is great. There are other ones you can use though. So there are some online ones. There's a company that contacted me about one. Let's have a look what it's called. And I chose not to do a video on it because it wasn't very featureful, so I couldn't do the stuff that I can do in Eagle. It was called Easy EDA, and it's an online circuit thing. So this is Easy EDA. You can use this kind of thing if you wanted to, and all you do is I assume you just drag over stuff, new schematic, left, and then you pop it on, and this is just the schematic bit. Let's just throw a bunch of stuff on there. What's that? An adjustable regulator. And then we can click on Convert Project to PCB. Oh, we have to log in, I'm not doing that. Anyway, it's an online version of a very limited Eagle. So it isn't as good. You can create parts. What's this wizard thing? So yeah, you can create your own parts and assign a different package to it if you want, and also different naming things, and you can do it all in here. However, I didn't like it, and I didn't think it would be useful for people to pick up. In fact, I think it's worse than trying to use Eagle if you've never used it before. Using a bit of software like that doesn't act like a package like Altium or like Eagle, you're not going to be doing yourself any favors. When most people, I say most, that's not quite true, but a lot of people will do tutorials online using Eagle, or you'll be able to download an Eagle parts library, or you'll be able to pick up their projects with a schematic file that you can load up in Eagle. If you're going to be using a different bit of software, you can't take advantage of all those people's snippets, nuggets of knowledge that they put on the web. So I think it's important to use the same tools other people are using in the community, and that at the moment is Eagle until there is a different thing around. There is an Altium free version that you can use. Altium's like the premier kind of schematic and board creation bit of software. They use it in industry, so it's the kind of thing that you would learn about at university. You would learn how to use. Well, maybe only really recently. I guess maybe they didn't always use Altium in uni, and you would go out and do an apprenticeship and learn it there. But I never studied electronics, so this Eagle is the first thing that I ever used to do schematics on. I tried another one, but I can't remember what it's called, and it was relatively easy to use. But again, nothing I've found is as useful as I find Eagle. Even Altium is a little bit alien to me when I look at it, and so I prefer this. This is going to take a while. David Watts making Eagle fun while making it difficult for himself to accomplish simple tasks. Lol. I'm assuming there must be an easy way of naming these damn things, but I don't know it, so I'm doing it this way. I'm just gonna go. I could use the name tool, couldn't I? In fact, shall I go and click on that? Where is it? It's one of these ones. Invoke, wire. Which one are you? Well, you're none of those, are you? Label? There's a name tool, isn't there? Oh, there fucking isn't. Screw it. We're doing it my way. Oh yeah, I can see the symbol. There it is. There we go. I was on it the whole time. No, is that 10? 9, 10? Yeah. Still doing it. Oh, no. I'm still right clicking. I've got bad habits now from doing this for years. Is it years? I guess it is years now. I probably started doing electronics, I don't know, 4 years ago, I think. Is that accurate? Probably about 4 or 5 years ago. 14, 15, 16. So that didn't take too long. Now, correct me if I'm wrong, because I'm often am. Let's move this out of the way. I think I can just copy. Can I just copy this? Someone will tell me I'm wrong. If I just copy that and then swing it around here, does it keep the same name? Yes, it does. Oh. So that's TL1. It's connected to this line after the resistor. So there's a shortcut for you. Oops. So I don't have to go through and name them all again, thankfully. What am I going for? Not that one. Oh yeah, you said moving the board size. Yeah, because I've got my grid relatively small at 0.25 millimeters. When I move the grid, because I have to zoom in order to do that, when I move that box down, it's really hard to get those lines to be straight. So what I should have done is moved it as he said and then adjusted the numbers afterwards. It probably would have been a better idea. Oops. So what are we going for next? Five, 6, 7, 8, 9, almost there. 10. There's still a lot to do, obviously. Like we haven't connected up the microcontroller to be able to control the damn thing. I'm cheating with the power supply, so we're just using this 3-pin device over here, which is just a boost converter we're going to be using. Now it will only kick out about 200 milliamps, so we're going to have to be careful because our LEDs could take 100. So we have to make sure the rest of the circuit doesn't. Have I done that wrong? Make sure the rest of the circuit doesn't eat up everything. Oh, One of these things is exactly the same as the other. So this one's, I want TL11. It does say TL. Hang on a minute. Let's just delete it. Out 1, 2, 8, 9, 10, 11. So we'll delete that. So the other way you can do this is just by naming them, and we can connect them to the other thing. So TL10, yeah, and then name that one as TL11, just to sort out my mistake there where I copied over one. That's better. Oh, I can't be bothered to copy the rest, we're just going to do it manually. There we go. So now let's see how much more difficult that's going to make routing the board. I'm going to wager, I'm not sure what I'm going to bet here, but I'm going to wager it's going to be a lot. I'm just going to turn the heater off. It's pretty warm in here. Right, let's switch to the board view and have a look. And now we're going to rip up the things that are all freaking all over the place now, aren't they? So what have we got? So I'm going to have to flip it around a little bit, I think. So we can see these ones go here, that's fine. Over there's okay, over there's okay. The other ones don't appear to be connected. So that is an issue, isn't it? Why is that? So the more of these should actually be connected to here. We should be seeing 16 individual channels. However, we're not. Why is that? They're all named correctly. And these should all be connected. Except it's not. They are not connected. Yeah, they're not connected. I don't know how to connect them now they're copied. We're just going to delete them and do it again. Fuck it. All of them. I know that some of them worked, but fuck it. Oh, also, there may be swearing in this stream, so children should not watch. You also should be in bed if you're a child, so. How annoying. I still stand by my comment that it's going to make it very difficult to route this. If someone in chat tells me there's going to be a simple way of doing this, then they can F off, because I've started doing it manually now, so you are going to have to hold your tongue or your keys. I give up. I give up. Right, let's get the name tool out. We're doing it again. TL1. Yep. Let's have a look at that name actually. Let's just copy that. Okay. Oops. Right, name TL2. This isn't going to get boring for any of you, is it? Wouldn't it be great if it just went, would you like to rename all of the segments in this chip, and I'll be like, yeah, that'd be great. Can you do it according to this convention? Thank you. There's probably a user programming language thing for that, isn't there? Oh, stop deleting things, David. What are you doing? I'm getting tired, I think that's what it is. Did everyone have a nice weekend? Any cool plans for the winter break that will be coming up shortly? There we go. That looks a little bit more like it. And rather skillfully, or luckily perhaps, I have put them all in order, which is nice, apart from the top section here. What's going to be more awkward? How about... Oof, is that going to be easier? I think it probably will. I think having it that orientation will be easier. I'm not sure. What do you think? Is that the best orientation to put it? I mean, it's going to make it relatively easy to route these parts over. I'm well aware I'm wasting a bit of space here. In fact, do you know, every time this happens, you'll experience this when your grid doesn't quite match the pitch settings on whatever your chip is, or you know, the distance between here doesn't measure your grid, doesn't match your grid, and you get this really massively annoying thing. What I used to do, that's kind of funny, isn't it? What I used to do is just change my grid, but the absolute easiest thing I found is just to start from the chip first. And then you get a much cleaner line coming out. So let's do that, and then that. And then we've got another one here. Oops. I like things to line up, so we'll do that. So Dave is, during the winter break, he's going to get a Pi Zero portable and Game Boy cartridge reader writer stuff. Maybe 1K challenge on hackaday.io also. That's cool. What's the 1K challenge? No, it's a bit hinky. I don't think I like that, but that is the way it's going. Oh, there's a thermal pad there. Okay. God, where's that one going? All the way over there? I've just broken my rule. I didn't start from the chip. There we go, that looks okay. Oh, sorry, I just hit my mic there. Write a program that fits in 1K. What kind of program? There you go, Dave. You can post links now if you like. I'm going to have to avoid going under the bottom of this chip, I think, unless it's on the bottom side of the board, but I'm not sure if I can fit a via in just there. And there's not an awful lot of space to come down here, so we'll drop over here and we're going to double back on ourselves, I think. And then we've got enough space here, so let's do that and set a via and drop down there. Oh. I know I'm not quite what I wanted to do. We'll go back and change this. It's all right. Nothing is lost. I'm just checking I've done the rat's nest thing so I can see that there's enough room for my wire when I come down here. Look. And then we'll just jump up a little bit there and we'll stick in. Oh, no. Up one more, then down. There we go. I just wanted to check that was going to route okay. And that looks like it's sufficiently far away from that thermal. They could be close together, but I like to keep the pitch roughly the same with the wires when I'm going around. So Hackaday, let's have a look at that, shall we? So this is the 1K challenge, 1 kilobyte challenge. The only thing is what you can do is 1 kilobyte of program memory. So do you have to make something that's working, or do you just write the program? Why am I asking you? I could read it. Microprocessor, blah, 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 gigabytes of memory, microcontroller didn't always hold 100 kilobytes of flash. External hardware such as LED switches and 7.4 series logic chips are allowed and are encouraged, but the machine code must be less than a kilobyte. All right, you can certainly get some displays going, by which I mean like 7-segment type deals, or an LED matrix maybe. So Monday, the January the 5th, it closes. Okay. Is there any way to see what people have entered? Submissions, 34, okay. Ultrasonic distance sensor, and it's got a display. Wow. 7 LEDs with only 2 GPIO. Miniaturized electronic dice based on 80x85. How would you do that with 2 GPIO? 4, 4. Well, you could do 8 with Charlie plexing, couldn't you? Is that right? I think you can. We've got some other things. So Atari 2600 sound cartridge. That's a Nyan cat, isn't it? That's amazing. That's very clever. I like that. What's on the board? Do you know, I can't see a microcontroller at all. I don't know if any of you can. He must do. He's got a programmer there, so I mean, I could read the project and find out, I guess. So what is it? He's got an SMD 80Tiny85. Okay, so it is tiny. Interesting. Do you know what? I'm going to take a look at that, but writing small code is not, it's not my forte. I'm more into writing big commented code and that has lots of functions to do individual things. Fast code generally, but not necessarily small code. So that'd be interesting. Have you got any plans, Dave, for what you're going to do? So let's route the rest of this stuff. We're going to rip up this thing because I hate it. I hate it. There we go. So we probably need to come down. I'm sort of stealing the space where I wanted my microcontroller to go, and that's certainly going to have some wires on the bottom. That's annoying. Where are you, red one? There you are. I keep pressing the rat's nest tool out of habit rather than need for it, really. I don't need to come all the way over there, do I? Well, that's going to bug me. God, I'm making a mess here. That's probably not really enough clearance for that wire, but we're going to go with it. Just destroying any kind of ground plane that would be there, I think. That's what Dave said. Yeah, the traces are relatively thick. I can reduce them if I want to, but at the moment I'm happy with the way they are. I think it'll be fine. Generally I like them to just be the same, or roughly the same width, not too much smaller than the size of the pins on the chips that I'm using, generally. Although with this ancient in comparison, the 595, it's very different. I still think there's enough room regardless of the size of these traces, honestly. We're going to have to rethink this though. Crumbs. Oh, so you've already done one, Dave. So you've got the Hackaday IO DC motorboard with an ATtiny 13. How do you program an ATtiny 13? What are you using? I could just read your page, couldn't I? That would be the sensible thing to do, but we'll do that later. So it is this one here, and I'll have a read through later, so that's cool. OSH Park boards, it looks like. Nice. Okay, I'll check that out at some point. I'm going to call it a night now, guys, because it is 10:15 for me right now. So it is getting late, and you can probably hear in my voice that I'm getting tired. I'm less animated than I was before. So I'll save this and I'll pick it up at another time. I'll probably refactor where everything's going to be, because I think I would like the microcontroller to have some more space with the bottom of the board. So maybe it can go over here and I can use it there, or maybe we can bring it. Maybe it could go on the back of the board, honestly. It doesn't really need to go on the front. Plenty of space though, so I'll get it sorted. Anyway, thank you very much for watching, and I will let the chat catch up so you can say goodbye if you want to. I can't really tell where we are in chat land because it's a bit difficult. And I'm going to go to bed. So thanks a lot. Okay, bye guys.